All right, so in this video, we're given this particular problem. We're told to prove that what we have right here is equals to what we have right there. So this is one of the application of our double angles, because we can see right here that what we have here is a double angle. So this is tan 2 theta. And if you can recall from our previous video, tan 2 theta is given as what? 2 tan theta over 1 minus tan square theta. So obviously, this is very vital in solving this particular problem. So what you have to do is to replace tan 2 theta with this identity, our double angle identity. So what we're going to do next is to fix this up there. So we have 2 tan theta over 1 minus tan square theta, then everything multiplied by 1 plus tan theta over tan theta. Now, if you can see this, what we have here, we have 1 minus tan square theta. Now, I want you to recall that under factorization, when we have 1 square minus tan square theta, this is obviously what we call difference of 2 square. This is an application of difference of 2 square. Because you can see that we have 1 square, this is 1 square, minus this is tan theta all square. I told you already that tan square theta is the same thing as tan theta all square. So this will obviously, if you remember the equation for our difference of 2 square, we are told that a square minus b square will be equals to a plus b times a minus b. So this is the general formula for our difference of 2 square. So if we apply it to what we have here, we'll be having 1 plus tan theta multiplied by 1 minus tan theta. So we can fill that in for this particular value here. So rather than having 1 minus tan square theta, we can have 1 plus tan theta multiplied by 1 minus tan theta. So we're going to have 2 tan theta over 1 plus tan theta, then 1 minus tan theta multiplied by 1 plus tan theta, and everything will be divided by tan theta. Let's just fix that under here. Don't forget, this is the brother division here. Everything here is over tan theta. So from what we can see here, I'm sure you can be able to identify that we have 1 plus tan theta here and 1 plus tan theta here. Easily this can cancel this. So what we'll be left with will be 2, we will have 2 tan theta over 1 minus tan theta, then everything over tan theta. So we can go on then to resolve this much more easily. So looking at what we have here, this is 2 tan theta divided by 1 minus tan theta. So I'll be making use of the division symbol here, just to ensure we decomplex this particular work. So this is still the same thing as this. And obviously, from our knowledge of mathematics, we know that when we have something like this, we can change it to times over. Of course, there's a over 1 here. So when we change it to times, the 1 goes up, and then the numerator becomes the denominator. So looking at what we have here, I'm sure you can see once again that we have, this is 2 times tan theta. And obviously from here, since we have a multiplication sign in between both of them, we can easily cancel this with tan theta. So obviously, we'll be able to arrive at a final answer of 2 over 1 minus tan theta. which was the initial work we were told to prove. So this obviously is the same thing as what our final answer was. So we have been able to prove that the left-hand side is equals to the right-hand side. All right, let's see a much more different example right here. We're told to prove that the 2 times cosec 2 theta cos 2 theta is equals to cot theta minus tan theta. Of course, you can see right here that we are obviously having our double angle again being represented. This is 2 theta, this is 2 theta. So obviously we're dealing with double angles right here. Now, I'm sure many of you will be thinking you've never come across a double angle for the cosecant of 2 theta, because obviously we dealt with just the sine, cos, and tan. So you probably are feeling, how are you going to be able to resolve this? Well, this is where your basic identity comes into play. I want you to remember that you were able to tell during our basic identity that the cosecant of a particular angle was 1 over the sine of the angle. I'm sure you remember this. So obviously, from here, you can decode that the cosecant of 2 theta will be the same thing as 1 over the sine of 2 theta. So obviously, what we have to do next is to now we have arrived at the sine of 2 theta, which is still under our double angle, but at this time, we know what our sine 2 theta was. Recall that our sine 2 theta was given as, if you find out from our previous video, was given as 2 sine theta cos theta. So obviously, I can write my cosecant of 2 theta to be 1 over 2 sine theta. Sorry, 2 sine. Yes, 2 sine theta, that's correct. Cos theta. Because now we're dealing with cosecant of 2 theta being 1 over sine 2 theta. So this is how we are going to be able to resolve our cosecant of 2 theta. So it's going to be given by this. So now we can go on to resolve this now that we have found our value for cosecant of 2 theta. We obviously know our cos 2 theta already. Now the value for our cos 2 theta from our previous video is given as cos square theta minus sine square theta. Of course, you have different other forms of it, as I showed in the previous video. But in this case, this is the version we'll be using, because I can see that I'm dealing with my sine theta and my cos theta right here. So I'll be able to move much better if I make use of this particular format. So let's try and fix this in. From here, we have 2. Now, instead of writing cosecant of 2 theta, I'll be writing 1 over 2 sine theta cos theta, then multiplied by the cos of 2 theta given us cos square theta minus sine square theta. So obviously from here, I can easily go on to dissolve these 2 here. This 2 here will easily cancel this one. So I'll be left with just cos square theta minus sine square theta over sine theta cos theta. So from your understanding of fractions, I'm sure you agree with me that I can split this fraction in this particular way. I can have it as cos square theta all over sine theta cos theta minus sine square theta all over sine theta cos theta. So if you go on to resolve this, you would see that this is very much looking like something you should be able to resolve easily, because cos square theta, I told you already, is the same thing as cos theta everything all squared, which is the same thing as cos theta times cos theta. So if you have cos theta times cos theta here, obviously you know that one of these cos theta can be cancelled out with the cos theta we have beneath here. And the same thing goes for sine square theta. This is the same thing as sine theta times sine theta. So one of these sine theta can be cancelled out with the denominator. So what you need to go on to do then is to bring out the resultant of that, and we'll be left with just one cos theta here. Have a cos theta over sine theta minus, we're left with just one sine theta now, sine theta over cos theta. Now don't forget, from your understanding of the basic identities, don't forget that we told you that the cot theta is equals to 1 over tan theta. And tan theta is the same thing as sine theta over cos theta. So obviously, I'm sure you would agree with me that cot theta, I'm sure you will agree that cot theta obviously will be equals to cos theta over sine theta. The reciprocal of tan theta is cos theta, is cot theta. So obviously this can be replicated as and be written as cot theta. And obviously you know that sine theta over cos theta is what? Tan theta. This has brought me to the right hand side, which I was told to prove. So I've been able to prove that the left hand side is equals to the right hand side. So this particular value here equals to what we have right here. All right, so I would love you to make an attempt on this. And we have 1 minus cos 2 theta over sine 2 theta. We're told to prove that that is equals to tan theta. So all right guys, I hope you enjoyed the video, and I hope to see you in the next video. Thank you guys. Bye bye.